Hi, Joe Cerrone. Today we're going to look at modeling the spice jaw right here as part of our 3D printer project and assembly model. If we take a look at that part, the completed part, I've turned on the planes so that you can see them. And if you right click on a plane and you click on the eye, you can show the planes. And if you look at the part, it's modeled in the front plane. Here's the right plane, which goes right down the middle. And then here's the top plane. So we want to try to keep these axes or these planes lined up so that when we get into the assembly model, if we take a look at the way the planes are set up, you can see that the part is kind of modeled right down the center. And that's one of the reasons manufacturers like Solidworks so much, is it has these design intents which allow the designers to make things as perfect as possible. If we look at how this part was created, we can use, I call it the wayback bar. It's this bar right here, and you'll see that if you hover over it, it turns to a little hand. And if you pull that hand up through the tree here, it'll show you how this part was created. And so it was created from a sketch that was the basic shape of this part, which is 64 millimeters by 36, plus another 9 and 16 for this little part down here. I made a few small changes to it. What I found was that the next step, and I'll talk about those changes as we get to them, is to model this component. And what you can see is that we modeled this feature right here and saw cut it. And then the hole here, the counter bore with the M5 hex head bolt, and then the 6 millimeter cutout here. And then I tweaked this a little bit by threading this with a 1/4-20 tap. Now, if I was going to manufacture this, I would use millimeters, but it's hard for me to get metric fasteners. It's a lot easier for me to go down to Ace Hardware and get a standard size imperial. So I just made these 1/4-20 for our purposes. And then I also put 2 threaded holes on the bottom here that were 1/4-20, because if we do create it according to the way the curriculum was written, we would have to use like self-tapping screws to use that. And we could do that, but since we have this hole wizard now, or this, I think they should call it the thread wizard, we can see how the 3D printed threads will work. Okay, so that's how this part was created. Let's get started and make that part. And so if we take a look at the blueprints here, we can start off on the front plane with a sketch, and we're going to sketch this basic 64 by 36 with this 16 by 9 little T down here at the bottom. So switching back to SolidWorks, File, New, Part, okay. Front plane, start a sketch. And we're going to model it on the front plane. And when we model that, what we're going to do is we're going to model it right along the center line. So we're going to go and create a center line. Now, I forgot to make the units to millimeters, so I'm going to switch that over metric. And then we're going to continue the sketch. Sometimes it likes to be difficult. So I'm going to create half of it, and then I'm going to mirror it, because SolidWorks likes symmetrical relationships. Then I'm going to start to define my dimensions. .36 9. $16. And 64. We're going to extrude that sketch, and I'm going to keep the face of the part in the front, and I'm going to extrude that at a distance of 32 millimeters. Something happened there, so I'm going to edit the feature. 32. There we go. All right, so that's the first part. Next thing we're going to do is we're going to sketch on this face here, and then we're going to create this shape right here. And again, we're going to create a symmetrical shape which we're going to mirror. And so we're going to draw half of this, mirror it, and then we're going to subtract this part here and this part here. Click on the face, select sketch, space bar, normal to. Sketch, construction line, vertical right up the center. Circle from here to this point. I'm not sure why it doesn't, there we go, to that point right there. That's going to be a 16 millimeter radius. Or 32 diameter. And I'm not sure why it's fighting me today, but it's not unusual. So what I want to do is to add a relation to keep that component tangent with that part. And so what I'm going to do is see if I can add a relationship here between this and this. And I'm going to say tangent. However you do that, it's fine, but we do want that geometry set like that. We'll put another line here on the side. It should be horizontal. And then we'll set that at, we'll trim that. Whoops. I need a line that goes around the perimeter. So I want a line from here to here to here. Now I can trim. Define this line here, which is going to be, oops, from about here, and then I want a tangent relationship here. So I want it to find the tangency point. And Solidworks is pretty smart. So I'm going to figure that's going to work. And then I'm going to put in that fillet of 3 millimeters right here. And I'm going to define this at 10 millimeters from here to here. Now the part's not fully defined. What I could do here is to trim it and then to see what's involved to fully define it. I think it wants, and this doesn't look tangent, it looks a little off, and so something happened here. So let's make sure that we add that relation by clicking on this line and say tangent, and then check to make sure that those lines are endpoint to endpoint. Sometimes you'll have the line kind of cross over. So that looks great. And then I'm going to mirror this about my center line, and I missed one line. And I missed two more lines. So let's get these two. It's Monday. And then I'm going to trim. Going to check this area right here. And it doesn't seem to want to bring over that relationship. So what I'm going to do is I'm going to add it again, because you can see there's a tangent relation and it's not on this part. So we say add relation, click on this line and this line, and then say tangent. Okay. So we still have some blue lines that we want to figure out why it's not fully defined. Sometimes you can just go in, and we might be able to fix it by going from the origin to this point and just go with whatever number that it gives you, and I'll say okay. And so that seemed to be the problem. It likes to know where it is in relation to the origin. Next thing I'm going to do is I'm going to save it before I go too far. And then I'm going to extrude cut. So I'm going to say features, extrude cut. I'm going to select the contour right here and right here. So 1 and 2. And I'm going to extrude cut those a distance of 32 minus 10, or 22 millimeters. And green check mark. All right, looks good. Next thing we're going to do is we're going to start another sketch, and we're going to create the hole feature right here. We're going to need to do the hole feature on the top, which we will probably need a plane for, and the two holes on the bottom we'll use Hole Wizard for. Okay, so let's do the easy one first. Let's do this 12 millimeter 24 millimeter deep circular cutout. And when you look at this, read the prints. And so in the front view you see the hole, and then in the side view you'll see the dotted lines that show how that hole is set. And you'll notice that it doesn't have the little cones on it. Okay, and when you start to work with CAD, you need to start to learn about the tools that are making the parts. Now, since we're 3D printing this is no problem. You can 3D print flat holes on the bottom, but you can't drill holes without a point. And so hole geometry for typical high strength drills is 118 degrees as an FYI. And we'll talk about that more as we progress in the course. Okay, so as we look at that, we're going to create that 12 millimeter hole, 24 deep. Click on this face, start a sketch, space bar, normal 2, sketch. Wake up the center by hovering around the edge, and then it should be smart enough to find the center. And again, it seems to be Monday for me today, so I'm not so happy with it, but let's go throw a center line in, see if that makes it happy. Try it again. We're going to try to wake this up. And there it is. And we're going to make that 12 millimeters. Now, while it's sketching, you can come over here on the side and you can kind of preemptively say 6 for the radius and green check mark it. And then when you put in the smart dimension, it'll go right to that value. We're going to extrude cut. (24 millimeters). And then we're going to work on the bottom. On the bottom here, we're going to use Hole Wizard, and we're going to locate these two holes that are on the bottom, and I'm going to use 1/4 holes. 1/4 inch meaning 0.250, 20 meaning 20 threads per inch, or 20 of those ridges. To use the Hole Wizard, we're going to go and we're going to select Hole Wizard, and then we're going to put in that information. So I'm going to say inches, ANSI, American National Institute, and then we're going to say we want a threaded hole, and we're going to make that 1/4 and then the depth on that hole is going to be 16 millimeters. It's not a bad idea to add a slight counterbore to that. We'll come back to that. So once you have the whole information defined, you click on the Positions tab, and then you click here, and then you locate that. And what I'm going to do is I'm going to see if I can grab that and track it a little bit. It's a little tough. I'm going to space bar, see if I can go normal 2, try it again. There we go. I'm going to put one here, and then I'm going to track another one right here. I'm going to go and add a green check mark it, and then I'm going to add, I guess I ended it too soon. Let me right click and go back to editing that. And what I want to do is go back to my positions and locate those, and they're going to be located 8 millimeters and 16 millimeters respectively. So we'll come here with Smart Dimension, and we'll say from here to here, 8, and then from here to here, 16, and green check mark, and check mark. There we go. Now it's got a simplified thread representation. We can go into some of the Solidworks settings and it'll put a bitmap of a threaded feature in there if we want to. When you use the Hole Wizard, it doesn't actually cut the holes in it, and I should have thought about that before I made the video. So that's one way to do it. Another way to do that would be to use the features and to create those holes with the, I'm just going to call it the Thread Wizard. So let's take a look at that. I'm going to undo that. That doesn't want to undo it. Let's just leave that for this point right now. Okay, so we have another hole to put in the top. And what I'm going to do is I'm going to show the top plane by right-clicking on it and show the eyeball there. And then what I'm going to do is I'm going to hold the Control key and drag this part, this plane up. And what I really want is it to be right at that point where it's tangent to it. And so I'm just going to do a calculation on that. And that's going to be 36 plus 9, 45. So the distance, 44, I'm going to say 45, enter, green check mark. And so I have a plane there. I'm going to start a sketch on that plane by right-clicking on it, start a sketch, space bar, normal 2, and then I'm going to drive a center line down the center of the part, and then I'm going to create this feature here on the top. And we're going to make it, I'm just going to stick with the way that it's here. I can use Hole Wizard to create those features. You're welcome to go ahead and use the Thread Wizard to actually cut those threads. But when we get ready to 3D print it, I can tweak those settings as we go into the modeling. Or we just buy some threads and dies from Harbor Freight and we just work the parts, which is how you do that type of work when you're working with metal anyway. Okay, so this is going to be a 6-inch diameter through hole, 10 millimeters deep. Features. And it won't let me do Hole Wizard. So I'm just going to have to sketch it. And I'll extrude cut that hole up to next. And then I'll do the same for the counter bore, which will be 10 millimeters, 4 millimeters deep. Features, extrude cut. And the depth will be 4 millimeters. If we wanted to add a thread component to this, we're just going to go ahead and use a tap or a die. And it looks like maybe what I'll have to do is to just get a set of metric taps. Okay, so that completes the model for the vice jaw. To make it look nice, if we want to, you can grab the beach ball here and just choose a color for it. Be sure to save your part. And that's it. Okay, that ends this video.